Road to Olympiad.
Welcome to RTO. Consider the following problem. Let Px be a polynomial with integer coefficients. Show that there does not exist distinct integers a, b, and c such that Pa is equal to b, Pb is equal to c, and Pc is equal to a. It should be pretty common that a polynomial can take on any value. However, today we are going to prove that we cannot find integers so that the conditions mentioned in the problem can be achieved. As usual, to do non-existential proof, we are going to use proof by contradictions. Pause the video if you like to give this problem a try, and when you are ready, keep watching to learn how to solve it. To solve this problem, we start by letting the given polynomial px to be equal to a0 plus a1x plus a2x squared until anx to the power of n, where each of the a0 until an are all integers. Notice that pa minus pb can be written as a1 times a minus b plus a2 times a squared minus b squared until an times a to the power of n minus b to the power of n. Here, notice that a0 is cancelled out during the subtractions, and each of the term in the bracket is a difference of power of a and a power of b, and thus is divisible by a minus b. So we can factorize pa minus pb into a minus b times qab, where qab is an integer. And then we can have qab is equal to pa minus pb, the whole thing over a minus b. By using a similar argument, we can have qbc is equal to pb minus pc, the whole thing over b minus c, as well as qca is equal to pc minus pa, the whole thing over c minus a. Given that pa is equal to b, pb is equal to c, and pc is equal to a, we can write these three equations we obtained just now into qab is equal to b minus c, the whole thing over a minus b, qbc is equal to c minus a, the whole thing over b minus c, and qca is equal to a minus b, the whole thing over c minus a. Multiplying the three equations, we can cancel out the terms on the right hand side and obtain qab times qbc times qca is equal to 1. And since each of the qab, qbc, and qca are integers, the only possible solutions here we can have are the absolute value of qab, qbc, and qca are equal to 1. This implies that the absolute value of a minus b and b minus c and c minus a must be the same. However, this is impossible because if a and b as well as b and c have the same difference, it is either both a and c are equal, which does not satisfy the condition given in the problems, or a, b, and c must be in increasing or decreasing order. But then a and c will not have the same difference as the other two pairs. In fact, the difference between a and c will be twice the difference of the other two pairs. And thus, there does not exist distinct integer a, b, and c such that pa is equal to b, pb is equal to c, and pc is equal to a. And this marks the end of our solutions. Post in the comment below if you have any thoughts on the video. And if you haven't subscribed yet, consider subscribing. This will really help us out. Anyway, see you in the next video. Thank you.